So in this screencast, I want to show a TDD approach in TypeScript. If you're not interested in seeing how I'd approach test-driven development in this kind of context, then just skip down on the article and you can see the source code for the test and the application code as well. Like I say, it's a really simple example just to demonstrate kind of how you would go about setting up a TypeScript project in terms of unit testing it in a test-driven way. So we've got our package.json with the dependencies as we installed as mentioned above. We've got our test file, as you can see in the file explorer on the left. We can run our npm test command, passing the -w option to Mocha, so we can see it's monitoring our file system, looking for changes, and we'll rerun the tests whenever those files change. So at the moment we've got no tests at all, we've got an empty test file, no application code at all. And with a test-driven approach, I'd always aim to start with the test file, getting the first failure as soon as I could. So I'm starting trying to import a calculator class. And you can see our IDE, because we're using TypeScript, is giving us some compile errors. So you can see here it cannot find the module that we're trying to import as expected. And this I would treat as our first failure. So our first test failure is a compilation failure before we've even got to anything actually running yet. So we can change that by simply creating a module like so. And you can see we've now got a different error message, different compile error, which TypeScript's giving us, saying that the calculator module was found, but it doesn't export anything, so it's not really a module. So it found the file, but it's not a module. So let's export an empty class. We can see that compile error has gone away, but we've still got no tests. So the console is saying I've run it, but there's nothing to run, no tests to actually run here yet. As mentioned, I'm using chai expect style of assertions, so we'll import those as well. Now we can get on to write our first test case. So we're testing our calculator. We can see Visual Studio Code here. It's giving us the IntelliSense information. So it's helping us out using the type information, using the type safety that TypeScript is giving us. Something you wouldn't get in plain JavaScript. Again, writing our it method to actually define a single test. Again, IntelliSense giving us the type hint information. So we just need to give it a description and a function, as you would do in JavaScript. So our first test, we want to say that when we instantiate our calculator, it's a stateful calculator, so we want it to store the calculated value and maintain that as we perform operations. So it should initialize with the calculated value of 0. And one thing you may find, as you can see here, is that when you get these kind of compile errors in your test code, the watch mode of Mocha may not always pick up those changes. It's basically due to how modules are imported in JavaScript and whether they're cached or not and how that's dealt with. So if you do save it and you don't see any new output from the console, then just hit Ctrl+C and then restart that process again, and you should see we've got our test being picked up now. It's quite obvious when this happens. We knew there should be a test running and we can see there was no test running, so just a simple Ctrl+C, run the process again, and it's running our test, which is now passing. So we know the test is being run correctly. So no test body, we would expect it to pass. So now we can move on and try and get it back to failing again. Okay, so we've instantiated our calculator. Now for our first expectation, we want to expect the calculator's value to equal 0. So again, you can see IntelliSense kicking in here because we're using TypeScript. We got this nice auto-completion with type safety. And we've got a compile error again, so back to failing. Not with the test failure in itself, but a compile failure. So value doesn't exist. So we'll simply add this property to the class. And now we've got a failure. Expected undefined equals 0. So we've not initialized our value with 0, or with any value indeed. So we've got our test failure, genuine test failure. So now we can go back to the source code and fix that problem. So we'll add a constructor, and in the constructor we'll set the value to 0. And switching back to the console, we can see Mocha has picked up the change, rerun the test, and it's now passing. So great, done one test, on to the next test. This time we want to actually start building out operations, and we're only going to go as far as one operation here just to demonstrate the process and to demonstrate the kind of framework setup that you have to do if you want to start TDDing in TypeScript. So the next test, we want to test the add operation, and we want to make sure that our add function, our add method, is going to return the value of the calculation. So that's what we're going to add next. So I want my test description to be as descriptive as possible. So it describes the action and performing the expected result. And it should only be a single thing that we're testing. So it should return a result of 5 when performing an addition of 5 immediately after creation. So it's quite specific in terms of what it's describing, but that's a good thing in my mind. So as before, instantiate a calculator. This time, rather than looking at calculator.value, we need a different assertion. So we'll say calculator.add 5. The result of that, the return value of that, should equal 5. Again, back to a failure, but it's a compile failure as before. We haven't got our add method yet. So we'll create the add method. Adding type information into the signature of this method. As we're using TypeScript, we can make use of this so that any parameters that are the wrong type would result in a compile error. We're just going to return 0 as a default behavior because I want to see this test failing properly. And switch into the console, we see that expected 5, but it was actually 0. So now we can switch to our calculator and we'll do the simplest thing possible, return the n, return the parameter value, and we've now got 2 passing tests. And I wanted to go for the simplest implementation possible, and now I'm creating another test which is going to force us to improve this behavior. And this is what I would do if I was working in the true TDD way on real production code. So this time I want to make sure that the result of our addition is stored as the calculated value, calculator.value that we saw before in our first tests. So again, we'll instantiate it, we'll call add. We don't need to test the return value because we've tested that in a different test case. I don't believe you should duplicate assertions in different tests. Just because you can make an assertion doesn't mean you should. Keep each test specific. So now we're performing add, and we expect calculated value, in this case, to equal 9. Again, I need to restart the test runner, but we can see it was quite obvious that we needed to do that. So now on running this, we can see we get a genuine test failure because the value is 0. We've not been updating that. So now we'll switch back to the implementation code again rapidly and fix this, forcing us to improve our implementation. Again, going with the simplest thing, not a full implementation. You could argue it's overkill for the add operation, but in reality this would be a massively rapid process and would only take a couple of minutes to complete. We'll be doing it with confidence that our test code and our application code is working exactly as expected. So now, our next test, we want to make sure that we can add more than one value together. So perform multiple invocations of calculator.add, and we expect the result, the return value of that, to be equal to the result of that final calculation. So add a new test method for this. This time, instantiate it, calculator.add one value, call it again, and then we'll add an expectation to say calculator.add called for the third time. The result, the return value of this, should be 12. Nine plus 2 plus 1. So it's failing, got a test failure on the console. Now switching back to the implementation code will improve this with our real implementation of add. So quite a simple code, but it's just keeping it simple to illustrate the point really. Okay, so now we've got 4 tests passing, which is great. Now we could stop there, but I want to add a final test because it's for behavior that I care about, which is to make sure that calculator.value is updated even when multiple additions are performed. We know it is because of the way we've done it and the code is so simple, but even if the tests are passing and it's a key aspect of the behavior of a particular feature, I'd always like to add a test for that if possible, if I can do it in a clean, specific way. So instantiate it, and a few values as before, and then add an assertion around calculator.value again. As expected, this passes. Now, one minor annoyance that we noticed in developing this is the fact that we had to restart the mocker process when watching the file sometimes. It was obvious if we were looking at the console output that we had to do it, but it is a bit annoying. One other thing you could do if using Visual Studio Code, as well as giving nice IntelliSense type information, is there are a set of good plugins available for it, and I use a TDD plugin, which, like the Mocha Watch option, it will monitor the file system for changes and run the npm test command each time the files change. And it's not doing this in a persistent process way like the Mocha option does. It's running npm test from scratch each time, so it doesn't suffer from the same kind of problems that watching the files on the command line as we saw did. It will rerun every test every time we save anything. And if you can enable this, you can save the test code, I can save the application code, and at the bottom I can see the results of those tests. When I get any test failures, I can see exactly why those failed, etc. So that's probably what I prefer, but I thought it was worth showing you the Mocha option in case that's your preferred workflow as well. So I hope this has been a useful demonstration of how to set up a TypeScript project in order to do unit testing and test-driven development, and I hope this illustration in this video has been a useful insight into how I'd approach it from a true test-driven fashion, using both compile errors and test failures to drive the development process.